Let's go back now to our original window. And now that we've got some sense of the machine code that goes with this program, let's try using a debugger to work with it running instead of just looking at it statically. So I'm going to start lldb a.out, and that gives me a debugger at the command line. If I run the program here, then it's just like running it directly. And I can say Alice, and it'll print hello Alice. The run command ran things all the way through, but of course, with the debugger, often our goal is to step through more slowly. So one way I can do that is by setting a breakpoint at main using b space main. So now, when I run again, instead of running all the way through, the code will run until we get to the first instruction inside the main function, which happens to be a push. I can step through these instructions using S. And you can see where there was a call queue to say hello, then the instruction pointer jumped inside of the say hello function, whose machine code is disassembled and showed here in a way similar to the way that OTool was showing it to us. So I can keep stepping through, and here when I get to fgetS, it ends up jumping into that function. I'm going to start over, and you can see that in this case the debugger has some idea that we're in the say hello function, but it only prints a few of the instructions. It's just showing us some local context. If you wanted to see the debugger thinks belongs to the whole function, then you can run the disassemb program, and it'll show you all of the disassembled machine code for the current function, and still show you the arrow where we are currently within that function. So that can be handy for getting some context and see how it relates to the disassembly that you got from OTool.